Hello, dear student. Today we are going to discuss height and distance exercise 9.1, application of trigonometry. First question: a circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with ground level is 30 degree. Now, the most important thing when we are solving the problem of height and distance, we have to draw a diagram. This is the first step you have to follow. Draw the diagram. Draw the diagram, because if you are not drawing the diagram, then you are not getting a marks in this height and distance. This is very, very important. Second thing, after that, after drawing the diagram, indicate the whatever the value is given, and after that you have to apply sine theta, cos theta, and tan theta, whatever is required, and to find out the value of unknown. This is only the two-step problem. Now, is in this question, first of all, we draw the diagram. In this, AB is nothing but the height of the pole. AB is height of the pole, and AC. AB is height of the pole and AC is 20 meter is the length of the rope, which is tied from the top of the pole to the ground at C. Now, in this question, we have to find out the height. This height we have to find out. Suppose this height is H we are taking, and this is the angle which is making by the rope and the height at the top. So first of all, we have to decide sine, cos, tan, which trigonometric ratio we have to take. So in the sine theta, this is hypotenuse, and tan theta hypotenuse is not coming, correct? So sine theta, if we will take sine theta, then we can write h by 20. So h is nothing but 20 into sine 30, that we can write 20 into 1 by 2, that is 10 meter. So in this way, this is one of the easiest chapter actually. Only you have to decide the diagram, and after that you have to find out. Now, next question. A tree breaks due to the storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Now, according to the question, if you will see, then we can, this is nothing but the tree, and in this part is broken, and after that it's filled down in this way, that is A dash B, which is making an angle 30 degree, and from the this length is given 8 meter. So we have to find out this height. So this height means we have to find out this value. So total length of this is nothing but this length plus this length, correct? So once we will add AB plus BC, then only we can find out the total length. Now, in the triangle, if you will see in the triangle A dash BC, in this triangle, this value is 30 degree. First of all, we have to find out this length. First of all, we have to find out this length. So for this, if we will take this divided by this, hypotenuse will not come, that only is that is possible in the tan theta. So tan theta is BC by A dash C. So BC value is 8 by root 3. Now this is the value is 8 by root 3. After that, we required this value, AB value we required. For the AB value, the length of this is same. So after that we can apply, we know this value. Then if we'll take sine theta here, if we will take sine theta, then this value BC divided by A dash B will get. So or cos theta, any value you can take, sine theta or cos theta, it depends upon you. Here cos theta we took. So cos theta is nothing but A dash C divided by AB. So A dash C divided by B, this is value is 8, and A dash B, just substitute the value, we got A dash B equal to 16 by root 3. This is 16 by root 3 and this is 8 by root 3. Correct? So this length is actually, this length is equal to this length. So just if we will add this value, then we will get the answer. 16 by root 3 plus 8 by root 3, 24 by root 3, and this is 8 by 8 root 3. So always, second important thing is when you are getting the root value in the denominator, so always rationalize this value, root 3, root 3, root 3, we have to multiply, and this become 8 root 3 meter. In this way you have to solve. Now third question we will see. Now in the question number third, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at 1.5 meter. So first height is given for the first children below 5 years. So according to this, this is the length 1.5 meter and inclined at an angle of 30 degree to the ground. So from the top to the ground, it is making an angle 30 degree. Whereas for the elder children, she wants to have a steep slides at a 3 meter. This is the height just 3 meter and inclined at 60 degree. This is 60 degree. This is the two things. What should be the length of the slide in each case? Now we have to find this. So just use what the 3 values are given, 1, 2 and 1 unknown. So if we will take sine theta, then this is nothing but sine theta equal to 1.5 divided by AC. So AC we can write 1.5 divided sine theta is 1 by 2. So this is 3. Same way we can find out for this value. So just you can see the solution. Sine theta equal to BC by AC and AC value is 3 meter. Similarly, for the PR, sine 60 degree equal to 3 by PR. 3 by PR and PR value is 2 root 3. Just by rationalizing, this is 2 root 3. So in this way, we can find out the value. The angle of elevation of top of tower from the point on the ground, which is 30 meter away from the foot of tower, which is 30 degree. Now, according to the diagram, this is the case. AB is given from the ground. It is 30 meter and 30 degree angle. Find the height of the tower. If we want to find out the tower, then this value divided by this value is nothing but the 10-30 degree. And 10-30 degree value we have to find out. That is 1 by root 3, and BC we have to find out BC by 30, and BC value just after rationalizing 10 root 3 meter. Now question number 5. A kite is flying at a height of 60 meter above the ground. This is the 60 meter above the ground it is flying. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string, assuming that there is no slack in the string. Now this value we have to find out AC. So this is given 60 meter. So we can write here sine 60 degree is 60 divided by AC. So this is the value sine 60. We have to substitute 60 by AC. So AC value just we have to find out after calculation. We got 60 into 2 by root 3, and just after rationalizing we are getting 40 root 3 meter. Now, question number 6. Question number 6. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. The angle of elevation from his eye to the top of the building increased from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. Now, according to the given question, if we want to draw the diagram, so this is the diagram where the boy is standing at the, and this is the building, and this is 1.5 meter tall boy. So according to that, this is the length of the boy, and this is tall of building length is this. Now from here, this point, he is moving towards this side, and is making an angle 30 degree and 60 degree because position is changing. So we have to find out this value x and y we have to find out. So this is 1.5 meter. So definitely this is also 1.5 meter. So first of all, in the given triangle BFD, if you will take B, F and D, this bigger triangle, if you will take, so tan 30 degree is nothing but BF divided by total length is this x plus y. So in this, just we have to substitute the value 1 by root 3, tan 30 equal to 1 by root 3. After that, this is the value 28.5. This is the length 28.5 divided by x plus y. This is the according to this 30 degree. After that, tan 60 degree if you will take in this triangle, if you will take, then we can write 28.5. This is the length BF divided by EF. So we will get the value. We will get the value y equal to 28.5 divided by root 3. After that, just we have to substitute this value in the equation first. And we get the 28.5 divided just x plus 28.5 divided by root 3. And after doing calculation, x value is 28.5 root 3. Root 3, 1 by root 3. This is a common value. So after solving this, we are getting 19 root 3 meter. Hence, the distance he walked towards the building is 19 root 3 meter. So just you can refer this calculation, and this is the total value of what the things we discussed. Now, question number 7. Question number 7. From a point on the ground, the angle of elevation of bottom and top of a transmission tower. So this is the tower. This is the tower whose top is this point and bottom is this point. Now, fixed at the top 20-meter high building. So this is the tower. AB is the tower, and it is fixed in the 20 meter. This is the building length 20 meter, and AB is the length of the tower. Find the height of the tower. That means we have to find out the AB. Now to find out the AB, just first of all you have to visualize this is 45 degree angle which is making by this triangle DBC. If you will take one triangle, first of all you have to visualize the thing. We can find out this value just by tan 45. If we will take this is nothing but 20, that is BC divided by DC, that is DC value, and tan 45. So DC is 20 we can write because this is 1. Now first of all this we got 20 meter. After that, from this triangle total this value, this is, suppose this tower value is x. So 20 plus x, if you will take this tan 60 degree, then 20 plus x divided by 20. So in this way we can find out. Analyze first, and after that we can take the value. So in the triangle BCD, first we took, as we discussed, 1045, CD length is 20 meter. Now after that, in the triangle ACD, bigger ACD, here also 1060 degree we can take, 1060 degree this value, and AB value we can find out easily. And just after doing the calculation, we got 20 root 3 minus 1 meter. Next, question number 8. A statue 1.6 meter tall stands on the top of a pedestal. So, from a point on the ground, the angle of elevation of top of the statue is 60 degree. So, according to the question, this is the statue which is on, this is the length 1.6 meter. Find the height of pedestal. So in this is the height of a statue 1.6 meter, and which is making angle first. This is making 60 degree, and with this 45 degree. Now previous question and this question is completely same. So first of all, what we have to do, suppose this is the length x meter and this is the height h. Now first of all, what we have to do, in the triangle ABD, bigger triangle, in the 1060 degree, first we have to find out 1060 degree. This is the total length 1.6 plus h divided by x meter. This is the first, we have to find out this value. So h equal to root 3x minus 1.6. Now in the triangle 1045 is, we can write in the triangle of CBA 1045 is h by x. So h equal to x, and we have to substitute this value. We have to substitute this value h equal to x here in the equation first, and we will get the value of h. After substituting the value, h root 3h minus, this is 1.6, and 1.6 divided by root 3 minus 1 into root 3 plus 1, root 3 plus 1. Just rationalizing the value, we got this answer. Question number 9. The angle of elevation of top of building from the foot of tower is 30 degree. And angle of elevation of the top of tower from the foot of building is 60 degree. If the tower is 50 meter high, then find the height of the building. This we have to find out. Now, in this question, first of all, what the things are given, we have to draw the diagram. BC is equal to 50 meter, which is the height of the tower. AD is equal to h meter, we will take height of the building. Angle of elevation of top of building from the foot of tower is angle DBA is given. This is 30 degree. From the foot of tower to the height of the building is 30 degree. And this is given from the angle of elevation of top of tower from the foot of building is 60 degree. This value. Now, suppose the length between the building and the tower is x meter. Now, in the triangle BAD, first of all, we have to take the in the triangle B, A, and D. This is the triangle. First, we will take. Now, 1030 degree equal to h divided by x. So, one relationship between the h and x we will get from this triangle. That is h equal to x by root 3. Similarly, we can take the triangle ACB, CBA or ACB, anything you can write. That is 1060 degree. If you will write, that is 50 divided by x. And from the first equation, we have to substitute the value of x, 50 by root 3, h equal to x by root 3. So h equal to 50 by root 3 into 1 by root 3, that is 16 2 by 3 meter. So this is the height of the building. Question number 10. Two poles of equal height are standing opposite to each other on either side of the road, which is 80 meter wide. This is given. AE and BD are two poles which is at the distance of 80 meter. From a point between them on the road, the angle of elevation of the top of the pole 60 degree and 30 degree. Find the height of the pole and distance of the point from the pole. Now, according to the question, let the AB be the width of the road. This is the total length of the width. On both sides of the road, pole AE equal to BD equal to H meter. This height is given. This is the two pole. And from here, we are taking this two pole. Now, let C be any point on AB such that from the point C, angle of elevation is 60 degree and 30 degree. So this is the angle of elevation. This is 60 degree and this is 30 degree. Now let BC equal to. Now let BC, this value is X, then this value is 80 minus X. Now in the triangle CAE, this triangle, first 10, 30 degree, if you will take, then this is H by 80 minus X. So there is a relation between the H and X in one equation, and same we will take the triangle CBD. Here also 10, 60 degree equal to BD by BC, H by root 3. So in this type of question, two equation we will get. After that, one value we have to substitute in the other equation and we will get the result. So we have to substitute the value H root 3, H value equal to root 3x. So root 3x into root 3 plus x equal to 80. So from here, we will get the value 4x equal to, so x equal to 20 meter. Now, after putting in the equation second, H equal to 20 root 3 meter. So this is total AC value is 80 minus 20 equal to 60. So height of the pole is 20 root 3 meter and distance of the point C from the pole is 60 meter and 20 meter respectively. Now question number 11. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. This first value is given. This is the diagram. This is the tower which is making an angle 60 degree from the top. From another point 20 meter away from this point on the line joining this point to the foot of tower, the angle of elevation is 30 degree. Now this is 60 degree and this is 30 degree. Find the height of the tower and width of the canal. So first of all, we have to take the height of the tower is H meter and this is the canal. Now from the triangle ABD, first of all, what the value A, B and D. This 10, 30 degree, we can write AB by DB. 10, 30 degree equal to 1 by root 3. AB value is H and DB is, we can write 20 meter plus X meter. So whenever the two triangles are there, so first of all, we have to take one condition for that. You have to take one triangle. After that, another triangle just we have to take and substitute the value. This 10, 30 equal to 1 by root 3. We can write H by 20 plus X. So 20 plus X equal to root 3H. Similarly, we can take 10, 60 degree and here root 3 equal to H by X. This value we have to substitute in the first equation, and after solving all, we get H equal to 10 root 3. So height of the tower is 10 root 3 and width of the canal is 10 meter. So this is the two value we got. Next question we are going to see. Question number 12. From the top of 7 meter, high building. The angle of elevation of top of the cable tower is 60 degree and the angle of depression its foot is 45 degree. First of all, we have to draw the diagram. So AD we have to take 7 meter, which is the height of the building. And BC, let H meter be the height of the cable tower. This is the cable tower and this is the height of the building. So according to the question, from the top of the building D, this is the building D top, the angle of elevation and depression is 60 degree and 45 degree. Angle of elevation is nothing but we can write like this 60 degree and angle of depression is 45 degree. So this is 45 degree. We have to find out the height of the tower. So height of the tower is, this is the 7 meter high, already it's there for the building, and we have to find out this length. So the distance between these two is suppose x meter. So we can take first in the triangle BAD, tan 45 equal to, tan 45 is AD by AB. So 1 equal to 7 by x, x equal to 7 meter. Now in the triangle CED, if you take the triangle CED, so this is 60 degree and we have to find out the value of CE. So CE we can write CB minus B divided by AB. So once we will find out the value of tan 60 degree equal to H by H minus 7 by X, and X equal to 7 meter, we have to substitute here and only one value unknown H, just we solve and get the result root 3 plus 7 root 3 plus 1. Question number 13. As observed from the top of 75 meter high lighthouse from the sea level, the angle of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, then find the distance between the two ships. So according to the question, this is the diagram. From the top of the building, suppose D is the top of the building and angle of depression is given. So first of all, 30 degree will come, after that 45 degree. So this is the 30 degree and this is 45 degree. So let CD 75 meter be the height of the lighthouse from the sea level. A and B is the position of two ships on the sea level on the same side from the point D of the lighthouse. So angle of depression is, this is the angle that you can see. Now let the distance between two ships AB equal to y meter. This AB equal to y meter and BC equal to x meter. So tan 30 degree, first of all we will take tan 30 degree. So tan 30 degree we will take in the triangle ACD. Always try to take the bigger triangle first. So tan 30 degree we can write CD divided by AC. So CD is nothing but 75 divided by AC value is x plus y. After that tan 45 we will take. So here first of all, after substituting the value 75 divided by x plus y, this is the first equation. And tan 45 we will take, this is CD by this, that is the height of the tower, 75 by x. So x equal to 75 meter, we have to substitute here and we will get the value of y. 75 plus y, 75 root 3, y equal to 75 root 3 minus 1. So this is the distance between two ships. Question number 14. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground. So this is the length of the girl, height of the girl. This is the height of the girl from the ground. So this is the height. The angle of elevation of balloon from the eye of the girl at any instant is 60 degree. So initially suppose 60 degree is here. Initially 60 degree is this, is the 60 degree. After some time the angle of elevation reduced to 30 degree. So after some time, the balloon position go from here to here with the uniform speed 30 degree. Find the distance traveled by the balloon during the interval. When the angle from the 60 degree to 30 degree, so this what is the find the uh, find the distance traveled by the balloon. We have to find out this distance. Now, in this question, what the value is given in the diagram, we can write here AD equal to, this is the value A and D. This is the height of the girl standing on the horizontal line, AD. FH equal to EB equal to 88.2. So this is the value FH. This is the total equal to EB equal to 88.2 meter, the height of the balloon from the line AB. Now at the eye of the girl, when it is making an angle of elevation is 60 degree and 30 degree. This is the 60 degree and this is the 30 degree. So FG, we can write FG equal to EC, and height of the girl is 1.2 meters. So 88.2 minus 1.2. So this is the length of the, correct, that is 87 meter. So distance traveled by the balloon is, suppose this is the distance y meter, and AH equal to, this is the value AH equal to x meter. Now DG equal to x meter and GC equal to y meter. Now in the triangle FGD, F, G and D, first of all, according to the 60 degree, this is the value. So 1060 degree, we can write FG divided by DG. So this is the value. FG is equal to total 87 meter divided by x. This is the length x for the when the angle of elevation is 60 degree. So 87 by root 3. Similarly, for the 1030 degree, is nothing but EC by DC. EC by DC, and we have to substitute the value. So 87 divided by x plus y. So whatever the value we got from the first equation, x equal to 87 by root 3, we have to substitute and we have to solve. So y value is this. After rationalizing all the value, we got 58 root 3 meter. So this is just the basic calculation and you got the concept. Question 15. A straight highway leads to a foot of a tower. A man standing at the top of the tower observes a car at the angle of depression 30 degree. Depression, that means the person is suppose here and this is the 30 degree, which is approaching the foot of the tower. This is the foot of the tower. Even with uniform speed, 6 seconds later, the angle of depression, so this becomes 30 degree to 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So what is the time it will take from here to here? It will reach. Find the time taken by the car to reach the foot of tower from this point. Now, according to the question, if you will see the diagram, this is the point D. At this point, the person is there at the point D. Angle of depression is 30 degree and 60 degree. Now, CD, let CD be the h meter and height of the tower, which is height of the tower. At the point D of the tower, a man is standing and observe the car at the angle of depression 30 degree. After 6 seconds, the angle of depression is 60 degree. So this is the corresponding angle we can write. So this is 30 degree, then this is alternate angle 60 degree, this is 60 degree, and and this is 60 degree. So this is nothing but the alternate angle. Now AB equal to y meter, BC equal to x meter. So in the triangle BCD, this is the 60 degree angle. So tan 60 degree we can write h by x. So this is the from the smaller triangle whose angle of depression is 60 degree. So root 3 equal to h by. Similarly, we can take tan 30 degree, and tan 30 degree will take, that is h by y plus x. Tan 30 degree h by y plus x, and this value we have to substitute x plus y equal to h root 3 x plus y, h equal to root 3 x plus y equal to 3x. So this is the second equation. Now time equal to, it is given that the car moves from the point A to B in 6 seconds. So let its speed be x k kilometer per second. So time equal to distance by speed. So time 6 seconds it is taking, and distance is y divided by speed is k. So y equal to 6k. We have to substitute from the equation second. We can write x plus 6k equal to 3x, 6k equal to 2k, 2x. So x equal to, this is the value, this is 3k. So time equal to total distance is x divided by speed is k. So x equal to 3k divided by k, that is 3 seconds it will car moves from the point B to C in 3 seconds. Now question number 16. The angle of elevation of top of a tower from 2 points at a distance 4 meter and 9 meter from the base of tower and in the same straight line with it are complementary. We have to prove that height of tower is 6 meter. This is the height of the tower is 6 meter. Now let CD be the height of tower. AC is a horizontal line on the ground. A and B are the 2 points on the line at a distance of 9 meter and 4 meter respectively, as shown in the diagram. Now, if this is the angle which is making theta, then this is complementary. This is 90 degree minus theta. So from the triangle ACD, if we will take, then tan 90 minus theta is equal to CD, that is h by 9 meter. So tan 90 minus theta is cot theta, h by 9. So similarly, BCD, if you take the triangle BCD, then this is tan theta equal to CD by BC, tan theta equal to h by 4. So first equation we got in the terms of cot theta, second equation we got in terms of tan theta. Just multiply both the equation. H square is equal to 36, h equal to 6 meter. So in this way we can prove. So I hope height and distance is crystal clear for all of you. So just in all the questions there are 2 triangles are there, and you have to just take one triangle, another triangle, and you have to draw the diagram correctly and solve the questions. Thank you.